Okay, so just to recap, so far in this chapter, we had some vocabulary, and then we talked about a central angle. A central angle was an angle that had its vertex at the center of the circle, and the measure of the central angle was exactly equal to the intercepted arc. So on a central angle, the angle and the arc are equal to each other. Now today we're going to talk about an inscribed angle. An inscribed angle is an angle that has its vertex on the circle itself. So what we see here, this would be an example of an inscribed angle. And the measure of an inscribed angle is equal to half the measure of the intercepted arc. This is the intercepted arc out here. So an inscribed angle is an angle with its vertex on the circle. The sides of that are chords. So the sides will be segments that have endpoints on the circle itself. And then the intercepted arc is the arc that lies between the sides of the inscribed angle. The degree measure of the inscribed angle is equal to half the measure of the intercepted arc. Okay, a few more things. If we have two inscribed angles that intercept the same arc, then they have to be equal to each other. So, for example, when we look here, here is the angle ABD. There is angle ABD right there. The arc that it intercepts is this arc out here. And we have a second angle, angle ACD, that intercepts that same arc. So the measure of angle ABD will be equal to the measure of angle ACD. And that's because if two inscribed angles intercept the same arc, then the angles are congruent, which means equal. Another thing that shows up in this section is if an inscribed angle intercepts a diameter, then that inscribed angle will be a right angle. So if we consider this inscribed angle right here, BAC, we can see that the arc that's associated with it is this arc out here, which is a semicircle. So that means the measure of angle BAC will be half of 180. So it's 90. That's a right angle. If an inscribed angle intercepts a diameter, then it's always going to be a right angle, because the diameter would cut off a semicircle, half of a circle. So let's take a look at a few practice problems. Here we have an inscribed angle, and that will be equal to half the intercepted arc. So here is our inscribed angle, right here. Here is the intercepted arc. That means the measure of angle WXY will be equal to half the measure of arc WY. So the measure of angle WXY will equal half of 62. So our answer would be 31. Next example here. The inscribed angle would be this angle right here. We're looking for the arc D to G to F right there. We know that the measure of angle DEF is equal to half the measure of arc DGF. So the measure of the angle is equal to half of the arc, but this time they gave us the measure of the angle and they asked us to find the measure of the arc. Well, the easiest way to solve this, we learned back in Algebra 1, is to multiply both sides by 2. So I end up with x equals 226. When we're given an inscribed angle and asked to find the arc, we multiply the angle by 2 to get the arc. When we were given the arc and asked to find the angle, we take half the arc to find the angle. Let's try yet another one. If you look at this problem, here we have a diameter. So that means that this would be a semicircle. So that would tell us that we must have a right angle here. So without doing any calculations, I know I'm going to get 90 degrees. Now this next one looks a little bit tricky. And the reason it looks a little bit tricky is they've asked us to find this arc right here, B to C. Before we find that one, I think we better focus on finding this one right here. I know that the angle equals half the arc for an inscribed angle. So 47 equals half of y. I know I can multiply by 2, and I get 94 equals my y. And then I know that I have a semicircle. Because I have a semicircle, I know that the 94 plus the x will equal 180, so my x will come out to be 86. Let's try another example. So number 5. Now in number 5, they've asked me for the measure of angle Jkl. So they want me to find this angle right here. Now to find that angle, I'd really like to know this arc out here. So I'm first going to find that arc. And to find that arc, I know that I have a full circle, 53 plus 65 plus x equals 360. So my x comes out to be 242. And then to find the angle that I want, I'm just going to call it y. I know that the y is going to be half of the 242. So y would be 121. Now this next one looks like a pretty complicated diagram, but let's take it just a piece at a time. So we're looking for angle RST, R to S to T right there. Now I really would like to know what that arc is that goes with it. Now the arc associated with it would be this one out here. So let's find that one first. I think we can find that one first because once again we have a full circle. So if I take the 54, that's a 64 right there. If I take the 64 plus the x plus the 75 plus the 139, that will equal 360. So 360 minus 139 minus 75 minus 64. I find out that x is equal to 82. And that means that the measure of angle RST, I'm going to call it y, so y will equal half of 82. So RST is going to be 41 degrees. And now let's talk about RUT. I have a feeling we can get RUT pretty easily without even doing any calculations. RUT is this orange one right here. It has the same intercepted arc. So it's going to be the same. It's going to be 41 degrees. Two inscribed angles with the same intercepted arc will be equal or congruent to each other. Number 7. So in number 7, I know the inscribed angle equals half the arc. So here's the angle. And here's the arc. That means for my equation, I have 8x minus 9 equals half of 158. Now half of 158 is 79. So 8x minus 9 equals 79. Add 9 to both sides. 8x equals 88. X would equal 11. The next problem. There's my angle. Here's my arc. And the inscribed angle equals half the intercepted arc. The inscribed angle was 67. The arc was 4x plus 58. And as I've mentioned to you a couple times, when you have the variable in the parentheses, I strongly encourage you to consider multiplying both sides by 2. That will get rid of the fraction quite nicely. 2 times 67 is 134 equals 4x plus 58. Subtract 58. I get 76 equals 4x. I divide by 4. We get x equals 19. Let's try another practice. Now this one is talking about the other concept. This is an inscribed quadrilateral. In an inscribed quadrilateral, all of the vertices are on the circle itself. And that means that the opposite angles are supplementary. So if I'm looking for angle J would be this one right here. These two are opposite angles. They have to be supplementary. X plus 92 has to equal 180. Supplementary. 180 minus 92, I get 88. In a similar fashion, if I'm looking for angle K up here, these two have to be supplementary. 45 plus y equals 180. So y would equal 135. And the reason is, in an inscribed quadrilateral, the opposite angles are supplementary. Let's take a look at another problem. This is another one with an inscribed quadrilateral. So I'm looking for angle P. I'm looking for this one over here. Now, that's a little bit harder because they haven't really given us enough information. I think what we need to do is we need to find the other arcs first. And let's begin by considering this angle right here. So that angle cuts off this arc out here. I know a piece of that arc. I know the 90 degrees, but I don't know that part out there. I would know that this inscribed angle equals half of its arc. So the 93 would equal half, and I don't want to use x in two spots, so I'm going to call this one y out here, would equal half of y plus 90. And again, to solve this, I would encourage you to consider multiplying by 2. 2 times 93, 186, equals y plus 90. So y would equal 96. Now that I know that, I could find the third arc, or actually the last arc, I guess. This arc right here. We'll call that W. If I take the 126 and I add the W and I add the 96 and I add the 90, 126 plus W plus 96 plus 90, that equals my, oops, oh, got a little bit big there. That equals my full circle. So the arc W comes out to be 360 minus 90 minus 96 minus 126 comes out to be just 48. Okay, now the reason that was helpful is now I know all of the arcs. So if I'm looking for angle P, which was my x, that's an inscribed angle. That's going to be equal to half of the intercepted arc. Well, the intercepted arc for angle x, here's angle x, so the intercepted arc for that one is going to be if I take the 48 plus the 96. So that comes out to be 72. And then to find angle R, I know that if I add the measure of angle R plus 72, I have to get 180. They have to be supplementary. So angle R comes out to be 108 degrees. And angle S has to be supplementary with 93. So if I take the measure of angle S plus 93, it has to equal 180. So I get 87 there. Quite a bit more complicated on that problem, but certainly not beyond your capabilities. Let's try another one. Now this one, the angle is on the circle. Equals half of the arc. So the x will equal half of the 112. The x will equal 56. Well, sorry about that. Next one. The angle is on the circle. It will equal half the arc. Well, there's the angle. So 80 will equal half, and then x squared plus 18x plus 16. Once again, whenever you have a problem like this where the variable's in the parenthesis and the 1/2's on the outside, I would strongly encourage you to multiply by 2 on both sides. So 160 equals, and then I'll have x squared plus 18x plus 16. That's a quadratic equation. So we need to move everything over to one side, so we'll subtract 160. X squared plus 18x, and then 16 minus 160 gives us negative 144. And this one I believe we can factor again. So when we go to factor it, the front ones are pretty straightforward. We need x and x. But for 144, I need things that multiply to give me 144, and they have to subtract to give me 18. So let's see. 144 divided by 6 and 24 I think will work. So I'll put a 24 here and a 6 there. I need a positive there and a negative there. And that would give me positive 18x in the middle. I set each of those factors equal to 0. Here I add 6. Here I subtract 24. And then we have to check to see that both of those make sense. Well, if I substitute a negative 24 in, and I take negative 24 squared plus 18 times negative 24 plus 16, yep, that one checks fine. If I put the 6 in, 6 squared plus 18 times 6 plus 16. Yep, that one checks too. And we check them by substituting in and we get a positive answer. Inscribed quadrilateral. Inscribed quadrilateral, opposite angles have to be supplementary. So if I'm looking for angle W, I know that if I add the measure of angle W plus 51, I have to get 180. They have to be supplementary. So 180 minus 51 gives me 129. As far as angle X goes, angle X is an inscribed angle. So the measure of angle X is going to equal half the intercepted arc, which is this one out here. 67 plus 101. So the measure of angle X equals 1/2 168. The measure of angle X equals 84. And for the measure of angle V, the measure of angle V plus 84 has to equal 180. They're supplementary. So I get 96. Let's try another one. Opposite angles are supplementary. So the 68 plus the 9x minus 5 equals 180. 9x plus 63 equals 180. 9x equals 117. Divide by 9. X equals 13. The next one. Here we have a diameter which means this is a right angle. 13x minus 1 equals 90. 13x equals 91. X equals 7. Opposite angles are supplementary. 62 minus 5x plus the 133 equals 180. Sorry about that again. The 62 plus the 133. So I have 195 minus 5x equals 180. I subtract 195. I get negative 5x equals negative 15. So x would be 3. Whenever you have an inscribed quadrilateral, the opposite angles, the ones that are diagonal from each other, have to add up to 180. They have to be supplementary. So that's how I set this one up. This one. Now on this one, we actually have one arc given to us here, and then we have an angle given to us right here. That angle will allow us to find this arc out here. And I think we have to find that first. So I know that the 114 will be equal to half of that arc X. I can solve that by multiplying by 2. So that arc X is going to be 228. And what that allows me to find then is, it allows me to find this arc over here. The arc that's associated with the inscribed angle that we're talking about with the X. To find that blue arc I'll just call Y. I know that the Y plus the 78 plus the 228 equals my full circle. So the y will be equal to 54. And that means that the 7x minus 7x plus 6 will be equal to half of 54. So 7x plus 6 will be equal to 27. 7x will be equal to 21. X will be equal to 3. So sometimes you have to find an intermediate piece before you can get to the one that you really want. Looking at this one, I think this is one of those instances. I think we need to find this arc out here. To find that arc out there, I'm just going to call it y. I know that if I take 92 plus y plus 162, I get the full circle. So the y will come out to be 106. And then that allows me to say that the angle equals half of the arc. So the angle, which is 7x minus 10, will equal half of the 106. So the 7x minus 10 will equal 53. 7x will equal 63. So x will be 9. This was the angle. Okay, another example. Well, in this example, I think this is the arc that we want right there. That's the one that goes with the angle 67. Now that arc, the angle is equal to half the arc. So if I were to multiply by 2, the arc is equal to 2 times the angle. So 2 times 67 equals that arc. So that arc would be equal to 134. So this is 134. And now I can use the whole circle. So the whole circle would be the 120 plus the 134 plus the 5x plus 21 will equal 360 degrees. Combining like terms, 5x plus 21 plus 134 plus 120, 275 equals 360. Subtract 275 on both sides. 5x equals 85. Divide by 5, x equals 17. Let's try another. Okay, so they gave us angle FGH. FGH is this one right here. And then they gave us arc FJH. So this is the arc. Now let's keep in mind the angle is equal to half the arc. This one is the arc. This one is the angle. So when I set up my equation, I would have 6x plus 21 equals 1/2, and then 17x minus 28. Every time that you have a variable in the parenthesis, like this, I would encourage you to consider multiplying both sides by 2. because when you do that, it eliminates the fraction. And you would have 17x minus 28 on this side. On the other side, you would have 12x plus 42. And now I'm going to subtract 12x on both sides, which would give me 42 equals 5x minus 28. I'm going to add 28 on both sides, which would give me 5x equals 70. And then I'm going to divide 70 by 5. And I get x equals 14. But this time they didn't ask me to find x. They actually asked me to find the measure of arc FJH. So I have to substitute back in. So I'm going to take 17 times 5 minus 28. So the measure of arc FJH is going to be 57. Now that was a pretty complicated one. So go back and rewind it if you want to. Here's another one. This one they gave us the measure of the angle. So this angle right here. So that's the angle. And then they gave us the measure of the arc. So this is the arc. And remember again, the angle is equal to half the arc. So the angle is going to be 5x minus 16. It's going to be equal to half of 12x minus 50. Again, when you have this situation with the x in the parentheses, I would suggest you multiply by 2. 10x minus 32 equals 12x minus 50. Subtract 10x on both sides. Add 50 on both sides. Divide by 2. X is 9. But this time again, it didn't ask us for x. It asked us for the measure of the angle. So the measure of angle STU is going to be 5 times 9 minus 16. The measure of angle STU would be 29. And again, if you need to stop it, feel free to stop it. If you need to rewind it, feel free to rewind it. Number 14. Now, number 14, they actually give you something for the measure of angle ABD. So they give us this one. And then they give us another angle. This angle they give us is angle ACD. Well, if you look at the yellow angle and the blue angle, you'll notice that both of those angles intercept the same arc. So that means that the two angles have to be equal to each other. ABD has to equal the measure of angle ACD. So we just set those two equal to each other. And that's because two inscribed angles with the same intercepted arc will be equal or congruent. We'll subtract 6x on both sides. We'll add 9. We'll divide by 7. And then we're finding the measure of angle of arc AD. Well, to find the measure of arc AD, let's first find the measure of angle ABD. So the measure of angle ABD will be equal to 56. And then the measure of arc AD has to be equal to twice as much, 2 times 56. So the measure of arc AD will be 112. The arc, again, is twice as big as the inscribed angle. The inscribed angle is only half of the arc. We just got a couple more examples to go through. So in this one, they gave us the measure of angle KLJ. So the measure of angle KLJ, this one over here. And then they gave us the measure of angle KJL. KJL, right there. Now, one thing that we can tell right away is we know that this angle is 90 because we have a semicircle. So I know that if I add all three angles in a triangle, 90 plus the 3x plus 2 plus the 7x minus 32, all three angles in a triangle add up to 180. 7x and 3x is 10x. I have 90 plus 2 minus 32, which gives me 60. I subtract 60. I have 10x equals 120. So each x is equal to 12. I'm asked to find the measure of arc KL. To find the measure of arc KL, I'm going to first find the measure of angle KJL. So it'll be 3 times 12 plus 2. So the measure of angle KJL will be 38. And then the arc has to be twice as big as that. So the measure of arc KL will be equal to 2 times 38. The measure of arc KL will be equal to 76. Okay, I believe that was the last one. I know that was a lot of examples, and if you didn't stay with me through all of it, you can pause it and go back. You can go through it several times, but it was kind of a